Our last speaker for today is going to be Andy Scholting. He's the president and the general manager for Nutrient Advisors, and this company offers consulting services in the area of compliance and manure nutrient management. Nutrient Advisors is filling the industry's need to accurately manage records in a user-friendly format and utilize nutrients produced by livestock operations, municipalities, and other industries as effectively as they possibly can. So with that, I would like to give control to Mr. Scholting.
Well, hello, everybody. Appreciate the opportunity to talk a little bit about what we're all most passionate about, and that is manure. Let me get the slideshow going here. Okay. So again, Andy Scholting with Nutrient Advisors out of West Point, Nebraska. Many of the locals here would consider Cumming County, Nebraska as beef capital of the world. We assist a lot of those large CAFOs in the area of environmental regulations. We have a record-keeping service. We help them comply with the DNR, the DEQ, EPA, NRCS, fill in all of your letters. We help our clients understand what needs to be done and help them to facilitate compliance on their yard. The fun part of our job is that each of those CAFOs is constantly producing a very valuable resource in their manure nutrients, and we understand that of all of the data that we have to keep from a compliance standpoint, it is the value of that nutrient that really has the only take-home value to the client or their crop producing neighbors. And so our niche, our focus is to achieve compliance, but with that help our clients maximize their returns from those nutrients, help them manage those nutrients at the highest level that they can. And a lot of times that is an education process with their crop producing neighbors to understand the tremendous value that they have in being a neighbor to a large CAFO. So for those of you who are in the information now category, and a lot of times we don't use words anymore, here's the subject matter. Here's my message, and I think that's the message of all of our speakers here today, is that manure is a very positive type way to fertilize our crops and to improve our soils. So why is manure so effective? A lot of the details and the science behind this, a lot of the other speakers have already done a great job to communicate. Manure is the best source of nutrients, and lots of them. And that's something that we don't talk about a lot, but we certainly see a tremendous advantage in the manure providing the ability to build soil fertility beyond what we can afford to do commercially. And if we think of our crops as eaters, manure provides a smorgasbord of nutrients for them to have what they need and when they need it. And so that is a great benefit of using manure as fertilizer. Organic material, we've talked a lot about that today, but certainly the organic matter in manure is something that we can't buy in town, and that has tremendous benefit to our soils long term. And in the end, when I consult with the producers, and I'm the boots on the ground that is trying to communicate all of the science and help our clients manage that manure at a higher level, it has to be economical. And manure certainly does dramatically increase yields on soils that are war or deficient in nutrients. So that is an exciting part of our job. I'm going to roll back the clock way back here. This is actually a publication that Leslie shared with me several years ago. This was done by Iowa State in 1907. It was one of their first extension publications, and I'll just go ahead and read this. But this is from the summary of a extension publication from 1907. Manure is one of the most effective means at the disposal of the farmer to permanently improve his soil. No other fertilizer possesses to so great a degree the power of restoring worn soils to productiveness and giving them lasting fertility. It accomplishes this result, however, not only by the actual fertilizing constituents which it supplies, but also improves the physical properties of the soil, increasing the amount of humus, which is generally deficient in worn soils, improving its texture and increasing its water absorbing and water holding power. Its value to the soil can scarcely be measured, for no other substance has equal power in maintaining permanent fertility. When I first read that, I was absolutely amazed that all of the science that we've talked about today, all of the work that we've done with our clients to try to get their manure to the right acre at the right time at the right rate, Iowa State scientists knew this in 1907, and I really can't put it into words any better than they did 110 years ago. That is what manure does for our soils, and it is absolutely something that it is really hard to value because it's so good. One really cool thing about my job is that we all want the same thing. Agronomics, economics, and environmental concerns. It is so often a public misnomer that if people are in business and if they are doing something for profit, then they must be polluters. And that is where a lot of our regulatory rules come from, with that mindset and that focus. But what's really exciting, and I won't bore you with the details of 4R, but when you think about it economically, if we put the right product at the right place, at the right rate, and at the right time, we achieve the best of all the worlds. We're certainly going to protect our environment the best that we can. We're going to increase the productivity of our soils and our farms agronomically. And then the bottom line, and this is what I have to come to the producer with, it has to make economic sense. And if you think about pollution or polluting our environment or putting on too much, if we've got nutrients running down the creek, we've got money running down the creek. That has tremendous value. And so we have to manage them at a level high enough that we can have the most economic return from our manure products. And when we do that, we're doing the best thing for our soils and our environment. So what is our purpose in applying manure? Well, we most often talk about fertilizer replacement. It's very easy to put an economic value on the fertilizer replacement part of manure. We can get fertilizer prices and put a value per ton or value per 1,000 gallon. What's really hard to put a value on is what we're talking about today, and that is repairing worn soils or improving our farms, increasing organic matter, and increasing soil health, which is a whole new area of agronomics that we're still all in the process of learning about. In the end, all of these things need to maximize yield and production and increase return on investment. Where we're in an area that is really concentrated with beef, and as we move into South Dakota and Iowa, there's a lot of pork, a lot of dairy. There's very concentrated areas, but typically they are surrounded by areas that can really utilize the nutrients produced at these CAFOs. And so we have to look at these purposes, these are our strategies, and understand what the value is of all of them to determine where is the best place for these manure resources. Manure is an offensive weapon for defensive farms. A lot of times our producers will refer to their farms or their soils as defensive. What they mean by that is that soil has a problem. Either it's low organic matter or light texture. It doesn't produce as well as what they might consider their offensive soils or their offensive farms. And so they farm those differently. They farm those in a way that prevents, like a prevent defense, they farm those in a way that prevents a disaster. They will plant hybrids that can survive in tough conditions, maybe that have good drought stress, or that maybe can perform in low fertility or low organic matter, but they'll do things differently to prevent the yield from really falling out of bed. Whereas on their offensive soils, they'll pour everything they can to it. What's really exciting about manure is that we can truly, over time, we can use manure as fertilizer and apply it to some of our defensive soils and create an offensive type of farm that will be on the top end of production. To increase organic matter, to increase water holding capacity. When we think about applying manure, not only from a fertilizing standpoint, but to change our soils. And I think several of the presentations prior to me illustrated the science of how and why that is done through organic matter, water holding, water infiltration, runoff. They all combine together to become more productive soils. And in my area here in northeast Nebraska, we have a lot of low organic matter soils, high in clay content, and very low fertility. And when we can go replace the organic matter that was there naturally years ago and replace the fertility that was there naturally, we've got our clay that can hold a tremendous amount of water. And we've really got something offensive when we can do that and change those farms for a lifetime. One last thing I want to show you is we've talked about technology a little bit, but we are writing prescriptions now for a variable rate manure application. In this farm in particular, on the upper left-hand side, you'll see the topography map. This is very typical for northeast Nebraska. We've got a draw going through, a stream running through the middle of the farm, a very level area. That's the most productive part of the farm. And then we've got some really steep clay hillsides. And then you move to the right, you can look at the organic matters and see the variability. We've got variability from the upper 1% to the high 3s to the 4%. And for those of you who are east of us in the Midwest, you'll consider all of that low. But we do have tremendous variability. Moving down in the lower right-hand side, you can see the potassium map. And we do have variability. You can see the potassium levels are certainly higher through the draw. The bottom left is a prescription that we wrote, and the rates really don't matter, but you can see how we've taken topography, organic matter, and potassium and come up with a hybrid prescription where we are applying a heavier rate of manure on the hills where organic matter is lowest, where our fertility is lowest. And then we've got a transition area, and then in the bottoms, we're basically applying manure in the bottoms for fertilizer and applying manure on the hills to improve that soil and improve that farm. And we do have solid applicators and liquid applicators available today that can do variable rate applications and follow those prescriptions. So that's something new and exciting that we're doing to try to improve a farm overall and unify that soil's productivity.